So we're now going to talk about the server structure and functionality of the BerraQuotes app. And I'm going to give you kind of a high-level view. And then in the next part of the lesson, we're going to zoom down and take a look at source code in detail. So basic purpose of the server is to define the BerraQuotes controller and the BerraQuotes service and the associated strategies and applications needed to actually run this thing as a Spring microservice. In this particular case, here's what the main entry point looks like from the point of view of the server that's implemented, the microservice that's implemented by the underlying Spring Web MVC. And this is the BerraQuotes controller. And it's responsible, if you recall, for working with the underlying Spring platform to map HTTP requests, in this case, GET requests, to the corresponding endpoint handler methods. So you can see we have a class called BerraQuotes controller. It's a public class. That looks pretty much like standard Java. However, we've also added a few other things. We've added in some annotations. And this thing called REST controller is a very important annotation, which you'll have to use. I think I might provide it for you. But you'll need to be able to do this annotation, add this annotation to ensure that request handling methods in the controller class, BerraQuotes controller, automatically serialize the objects into HTTP response objects. Now, you don't actually have to do this. It's done for you because you put the REST controller annotation there. Another important annotation we have is the auto-wired annotation, which indicates that the mService field of type BerraQuotes service will be automatically connected together by Spring's dependency injection framework. Remember, Spring is a dependency injection approach. And so by saying auto-wired, it will take care of creating an instance of the BerraQuotes service and then connecting that instance to this field. By the way, I follow a convention that's known as Hungarian notation. I think it's called the system variant of Hungarian notation, where anything that's a field has an M letter prefixed on it for member. It's beyond the scope of this discussion to talk about Hungarian notation in detail, but I like to use it because it makes it easy when you look at the slides to see what's a member of that particular class. Here are the methods that we define. You can see that they are methods that will get all the quotes for a given strategy. It'll get a specific quote for a specific strategy. It'll get a quote. You can also, and you can indicate the quote IDs when you get those quotes. You can also get back quotes by searching for a given string that appears in a quote, like the word baseball, for example. And then you can also search for a list of queries. So you might say baseball, and you might say over, and you might say slump. These are words that might appear in BerraQuotes. And what you get back in all these cases are lists of quotes. That all looks pretty much just like good old Java. However, you'll also notice some other annotations. All the annotations that have the @get mapping are annotations that indicate to Spring that this method is going to take HTTP GET requests as opposed to POST requests or delete requests or PUT requests and so on. And it informs the Spring framework that it should use reflection to extract out the portions of the underlying HTTP request that correspond to the GET header and use it in various ways. You'll notice there's also a couple of other things here. There are these strings like all quotes and so on, and searches. And these are strings that are used to automatically identify and route the incoming HTTP request, that's a GET request, to the corresponding endpoint handler method. Now, in this particular example, you'll see that I'm using strings in quotes. In practice, I would almost invariably use string constants. So that way you don't have to hard code yourself with magic string quotes, which becomes problematic over time. But I'm doing this just so you can kind of see what's going on under the hood. And when we look into the client side a bit more in the proxy, you'll see how it actually puts these various string names into the HTTP GET request header. There's also a couple of other annotations here. In particular, in this case, we're limiting ourselves to something called request param, and that indicates that the Java reflection mechanism should take a look at the GET request and then extract out the appropriate query parameters and other information that comes in the header, and then convert them into something that can be passed as parameters to the method. So in this case, for example, we're passing the list of quote IDs or the list of queries or whatnot. So that's what request param does. And there's also another thing called path variable, which is another variant of this, which can be used to handle so-called template variables in the URI portion of an HTTP request header and set them as method parameters. If you are deeply familiar with the way that HTTP works and the syntax of HTTP, this will all be very familiar. If you're not as well versed in this, then you'll just have to sort of learn these things. And I provide links here, as you can see, to documentation, and it explains it in more detail. This is also, by the way, a great place to use ChatGPT if you want a quick primer on how these things work. ChatGPT is very well versed in knowing how to interpret these annotations and how to explain how they relate to HTTP. So very much encourage you, whenever you have a question about this stuff, start off by asking ChatGPT, see if it gives you a sensible answer. And if not, Google it. If that doesn't work, feel free to post it to the Piazza discussion forum. But it's a really good idea to get in the habit of using these tools to get the answers. So let's talk about the structure and functionality of the BerraQuotes service. So we talked about the controller, and now let's talk about the service. So the BerraQuotes service defines methods called by the controller. And the controller just forwards to the service methods, and then the service just forwards to the designated implementation strategy. So here's the BerraQuotes service class. You can see that we give it an annotation to tell it that it's a service, and that indicates to Spring that this class implements so-called business logic. That's the application behavior. And it also tells Spring to use auto detection and auto wiring of dependent classes via something called class path scanning. And you'll get exposed to this. You don't need to know all the inner workings of class path scanning, but if you want to become a better Spring programmer, it's not a bad idea to learn about it. So that's another thing where ChatGPT will give you some good insights, and I'm happy to help out if you need any assistance with that. Now, what you can see we have here is we've got a local field called mStrategy, which is an array of BQ, BerraQuote abstract strategy objects. And these are the different ways to implement the strategies for handling the quotes. So you can see we have a sequential stream strategy, a parallel stream strategy, a parallel stream regular expression strategy, and a structured concurrency strategy. The order in which these objects are defined here matters, because we're going to use the position in the array as a way to get a lookup using an integer that's passed across from client to server to indicate the desired strategy to run. Not necessarily the most robust way of doing things, but it works and it's very efficient. Here's an example of an implementation. You can see here we say get all quotes, and this returns the quotes that are associated with that strategy. So when a client makes a request, it goes over here, it indicates which strategy. Let's say it's going to use the parallel stream strategy. That indexes into the array, gets that object, and we call the get quotes method on it, and that returns the quotes. And we'll see how that works later. Let's take just a quick look at the abstract strategy, or BQ abstract strategy abstract superclass, which defines the methods that are then used by the various implementation strategies that are going to extend that strategy class. So you can see we've got the BQ abstract strategy class, which defines a bunch of methods that don't have implementations. They're all abstract. And then you can see that there is, I'm sorry, they're not all abstract. The get all quotes is implemented, but the other ones are abstract. And then we have a bunch of implementations of that strategy that extend that class, that superclass, and override some of the methods. So would come as no surprise that the parallel stream strategy implements get quotes and search, and the two different search methods using parallel streams, sequential streams, of course, uses sequential streams. The structured concurrency strategy uses the structured concurrency mechanism, which, as we'll see, is more complicated. And then just for kicks, we have a regular expression version that further extends the parallel stream strategy to override the search method. This is just good old object-oriented programming 101. There's nothing deep or profound about this, just showing you how it all works. This should be reassuring for those of you who are comfortable with object-oriented programming, because it's basically the same idea. It's just that we've been able to extend the communication across a network so we don't have to run everything in one process. So that's the end of our overview of the server structure and functionality.